In a bold and astonishing revelation, scientists have announced the discovery of a space object unlike any previously acknowledged in the vast realm of our solar system. NASA, long celebrated for its pioneering missions and space exploration triumphs, has unveiled a celestial body that captivates the scientific community not only because of its size and location but also due to the strange, bright lights it emits. Lights that, some speculate, may even be artificial. Could this mysterious glow be a signal or a naturally occurring phenomenon? And if artificial, are we edging closer to the moment when hidden cosmic truths begin to unravel before our very eyes? This finding reignites long-held questions about our place in the universe and whether life, or intelligent life, might exist beyond Earth. The unusual characteristics of this object raise possibilities that could profoundly alter our understanding of what's out there. Could such luminous emissions be the product of some unknown geological activity, or are they evidence of something more extraordinary? These questions have propelled NASA's mission to uncover the truth behind this remarkable cosmic event. To trace the origins of this discovery, we must return to 2007, when NASA launched one of its most ambitious missions, the Dawn project. The objective was to explore two of the largest bodies in the asteroid belt, Vesta and Ceres. Equipped with three highly efficient ion propulsion systems, Dawn was able to make a revolutionary journey. This propulsion allowed it to break free from one gravitational body and travel to another, an extraordinary feat that traditional chemical engines couldn't achieve. It marked a milestone in interplanetary navigation. The spacecraft's first destination was Vesta, the second largest object in the asteroid belt. For over a year, Dawn closely observed Vesta's surface, beaming back high-resolution images and valuable data that offered a glimpse into its geological complexity and ancient history. Once the mission at Vesta was complete, Dawn set course for its second and most compelling target, the dwarf planet Ceres. Discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest and most massive object in the asteroid belt, nestled between Mars and Jupiter. With a diameter of approximately 950 kilometers, it was initially classified as a planet, later reclassified as an asteroid, and eventually designated a dwarf planet in 2006. This shifting classification alone reflects Ceres' mysterious and complex nature. But what truly captured the attention of scientists worldwide were the strange bright spots scattered across its dark surface, particularly within a large crater named Decatur. These luminous areas were unlike anything previously observed in our solar system. Prior to Dawn's arrival, only low-resolution images from the Hubble Space Telescope had provided distant glimpses of Ceres. But as the spacecraft approached, it delivered breathtaking clarity. Detailed photos revealed multiple bright spots, some of which appeared to shine as though lit from within. What could be causing such a spectacle? Were these spots patches of ice, salt, or something far more puzzling? Initially, scientists hypothesized that the light was reflected sunlight bouncing off icy surfaces. However, the reflectivity was unusually high, and the structure of the spots defied conventional expectations. The leading theory soon became that these were salt deposits, likely the remnants of salty water, brine, that had seeped to the surface and evaporated, leaving behind these dazzling, crystalline residues. This process, known as sublimation, occurs when a substance transitions directly from solid or liquid to gas without passing through the liquid state. This discovery was groundbreaking because it suggested that Ceres was not a dead, inert body, but rather a geologically active world. The concept of cryovolcanism, volcanic activity that emits water, ammonia, or methane instead of molten rock, gained traction. Cryovolcanoes had been theorized on icy moons like Europa and Enceladus, but finding evidence on a dwarf planet like Ceres was unprecedented. As Dawn continued its orbit, it transmitted more data that allowed researchers to develop a deeper understanding of Ceres' unique characteristics. The planet's outer shell appeared porous and sponge-like, composed of ice and hydrated minerals such as carbonates and clays. Beneath this crust was likely a rocky mantle and a possibly icy or briny core. This interior structure suggested that vast reservoirs of water ice could exist underground, and possibly liquid water, especially if internal heat from radioactive decay had persisted long enough. The ammonia-bearing clays discovered on Ceres added another layer of intrigue. Ammonia, commonly found in the outer solar system, lowers the freezing point of water. This implies that Ceres may have originated in the outer solar system and migrated inward over billions of years. The presence of ammonia-rich minerals also supports the possibility of briny subsurface oceans that could remain liquid today, shielded from space by layers of ice and rock. Among the bright regions, the most prominent was named Spot 5 within a Cater crater. This area was not a single light source, but a cluster of highly reflective patches, each with its own characteristics. Observations even revealed temporal changes, suggesting that some form of activity, possibly ongoing sublimation or intermittent cryovolcanism, was still at play. This was a revelation. An object long believed to be cold and lifeless now appeared dynamic and evolving. Cryovolcanism, in the case of Ceres, acts as a conveyor belt that moves material from deep within the dwarf planet to its surface. Once exposed to space, the brine sublimates rapidly, leaving behind striking salt formations. Over time, these changes can reshape the surface and create patterns that are detectable by spacecraft. But here's where speculation crosses into wonder. Could these glowing spots have an artificial origin? While the prevailing scientific opinion attributes them to natural geological processes, some researchers and theorists have pointed out their unusual symmetry, intensity, and recurring patterns across different regions of Ceres. Could this be the result of an unknown intelligent process? Most scientists caution against jumping to conclusions, emphasizing that extraordinary claims require extraordinary evidence. Yet, the tantalizing nature of these anomalies ensures that the question remains open. Ceres continues to surprise. It defies traditional definitions of planets and asteroids. It exhibits characteristics of both, yet aligns perfectly with neither. With its low density, ice-rich crust, potential subsurface ocean, and surface activities, Ceres emerges as a template for the study of habitability beyond Earth. Around the globe, expert reactions have ranged from cautious excitement to outright fascination. Planetary scientists, astrobiologists, and geochemists have turned their attention to Ceres, proposing new missions, simulation models, and even lab experiments to replicate its conditions. What they hope to find is not just more about Ceres, but about the formation and evolution of the entire solar system. Every mineral, every crater, every chemical signature on Ceres could be a clue to the origins of water, organic compounds, and perhaps even life itself. The Dawn mission has concluded, but the questions it raised continue to echo through observatories and laboratories. Ceres, once overlooked, is now seen as a cornerstone of planetary science. A world that may help us understand not only where we came from, but also where life might arise elsewhere in the universe. As we peer deeper into space with instruments like the James Webb Space Telescope, we may discover similar signs of cryovolcanism or surface anomalies on exoplanets or distant icy worlds. Could frozen planets on the outskirts of alien solar systems be hiding subsurface lakes? Might they host microbial life adapted to extreme conditions? In this unfolding chapter of space discovery, Ceres serves as both a mirror and a map. A mirror reflecting our thirst for understanding, and a map pointing toward the next great revelations in planetary exploration. As we extend our reach into the cosmos, the boundary between science fiction and science fact becomes ever thinner. Perhaps, in time, we will find that the universe has always held its secrets in plain sight, waiting for us to learn how to see.